Hello everyone. Today I wanted to talk about the fourth dimension. You've probably at least thought about it before. It's an interesting concept, having something bigger than our infinite three-dimensional space. It's very difficult to visualize, but instead of trying to visualize the entire fourth dimension, let's instead just visualize a fourth dimensional object. So think of, for example, a 3D cube. We can obviously hold one of these in our hand, and these are very easy to think of. So, if we want to imagine an object in a dimension bigger than ours, let's take an object from our dimension and put it in a smaller one. So let's take a 3D cube, for example, and put it in 2D space. Well, what does it look like? As you can see, it looks like a square surrounded by warped squares. These squares, of course, are not warped in 3 dimensions. You can pick up a cube and clearly tell the edges are not warped. Also notice, the most number of faces on a cube you can see in 2 dimensions at one time is 5. We know there are 6, once again you can count them, but we can't see them all at once because we can't see in 3 dimensions, meaning we can't see all sides of the cube at once. Now, let's talk about rotation. When you rotate a 3-dimensional object in 2D space, there are 2 ways to rotate it. We can rotate it 2-dimensionally, which looks completely normal, as you can see, but when we rotate it in 3 dimensions, notice that the 2-dimensional shapes are being warped and don't appear to be moving properly. The shapes are changing, they're moving in and out of frame, so this is obviously not normal for 2-dimensional objects. So when we put this all together, we can explain or expect a 4-dimensional object, or cube, to look like something very particular. It will look like one of the cubes is missing, it will look stretched, even though it's not stretched, like our cube. The faces were stretched in 2 dimensions, even though in 3 dimensions they're obviously not stretched. Also, there should be a strange way that it can rotate, because our cube in 3 dimensions, when it rotates, it looks very strange in 2 dimensions. So those are the 3 criteria we should expect. So, this is an image of a hypercube. I'll now open it up so you can see inside. As you can see, one of the cubes is missing, as we can only see 7, and there should be 8. Also notice, the hypercube can rotate in a way that appears to warp 3D space. The red cube on the inside moves to the outside, and all the other cubes change position. These are all factors that define our 3D object in a 2D space, so it makes sense for it to apply the same way from our 3D space to 4D space, to put an object from 4D in 3D space. If you're wondering how a hypercube is formed, imagine how shapes from other dimensions are formed. First, let's start with a square. We can take 4 lines and bend them into 2D space to form a plane. To make a cube, we would take 6 planes and bend them in 3D space to form a cube. So, to make a hypercube, we would take 8 cubes and bend them together in 4D space to form a hypercube. I'll pull it apart so you can see inside. Notice I have included the 8th cube this time. It is visible because I made all of the cubes transparent. Also notice the outside squares appear to be bent and small, warped. However, they are not, and only appear to be because we are scaling them down a dimension, similarly to how we scaled the 3-dimensional cube down into 3D space or 2D space and warped the sides. This all probably seemed confusing, but I hope I explained it well. If you liked this video, feel free to like and subscribe. If there's anything you didn't understand, feel free to ask me about it in the comments. You can also suggest a topic for the next video. Thanks for watching. Bye.